Welcome to Texas State University's Chemistry 2330, Introduction to Organic Chemistry. I will be your guide for these videos. My name is Dr. David Irvin. We'll begin with Chapter 1, Part 1, Covalent Bonding and the Shape of Molecules. So, as you may know, the study of organic chemistry is an extension or a specialty within chemistry where we look at the compounds that react with the atom of carbon. Okay, over 10 million organic compounds have already been identified. Thousands are being created or discovered each day. The cool thing about carbon is it's a fairly small molecule, but it can make single, double, and triple bonds with various other atoms. It has an intermediate electronegativity, which means it can make nonpolar or polar bonds with those other atoms, and it can make strong covalent bonds between itself, hydrogen, oxygen, nitrogen, sulfur, and halogens, and even some metals. Okay. So before we get too far along, I want to talk to you a little bit about the structure of the atom, because what makes carbon carbon is the fact of the number of protons it has in its nucleus. The nucleus is, of course, in the center of the atom and makes up most of its mass. However, it is not most of its volume. By having those 6 protons, we uniquely have carbon, and by the number of neutrons, we can have different isotopes. So for example, carbon-12 is our most common isotope. We have 6 protons and 6 neutrons. Okay, so most of the mass of the atom is taken place by that center nucleus. Okay, the rest of the atom is practically empty space, except for where the electrons exist. And the electrons exist in this boundary around the nucleus that balances the charge between the number of protons and the number of electrons that will give you a neutral species. And therefore, that takes up the majority of the space occupied by the atom is those shells, electronic shells. So let's talk about those electronic shells, okay? So the innermost electron shell can only hold 2 electrons, and that's our first energy shell. And we'll have different sizes and shapes of shells as we move out. The second shell we have has 8 electrons, and it entirely surrounds the shell number 1. And then for bigger atoms, other than carbon, we can have a 3rd and 4th shell, and they have additional electrons for each of the different shells they have. Okay, with most of the carbon compounds that we have and carbon, we're going to talk about specifically the electrons in the second shell. Okay, so because the shells are divided into subshells, we call those orbitals, and these orbitals have different shapes. Okay, so in our innermost shell, we only have an S shell. Okay, we only have an S orbital in that, and it contains 2 electrons. Once we get to the second orbital, we have the second shell. We have another S, so that's our second S shell, and we now have 3 p orbitals that are in that second energy level. Once we move out above carbon, we can get to having our 3rd S shell, our 3rd energy p shells, but then we can also have additional orbitals, and those are called d, and those have a different shape. And as we go further and further out for bigger and bigger atoms, we can get to more and more shells and more types of orbitals. In organic chemistry, we most of the time deal with just our 2nd level energy and our 2s shell and our 3 2p orbitals. Okay. So if we think about the relative energy of these orbitals right here, the innermost level, or the number 1 principal energy level, is our lowest in energy. It's the closest to the nucleus, and it's our lowest in energy. Now it can only be occupied by 2 electrons, so we only have 1 orbital, and that's the 1s orbital, as shown here, right here. So as we get to bigger and bigger molecules that have more and more electrons, we now can go to the second energy shell, which is a slightly higher energy. But within that shell, we have 2 different types of orbitals. We have the s orbitals here, and that has 1 shape and can occupied by 2 electrons. And then we have 3 equivalent p orbitals, which will give us a place to put 6 more electrons. Okay, once we go up to the next energy level here, we have to go to our 3rd energy shell, and in that case we would also have an S. We would still have 3 p's, but we would add additional orbitals here that are called d orbitals, and we can have a total of 10 electrons in those. Most of the time in organic chemistry, we're going to be talking about the inner core electrons that are in this 2s and the electrons in our energy, our number 2 energy level. And those are the ones we really want to play with most of the time when we're talking about organic chemistry. Okay. So another thing that we need to think about is that the electrons always fill from the bottom up. However, electrons are spinning, and when things spin and have an electronic component to it, that creates a small magnetic field. And so what you can have is, just like our planet, when it's spinning creates a magnetic field, electrons have that magnetic field too. So if 2 electrons are trying to occupy the same orbital, they can't both be spinning in the same direction because our north poles of our magnets would repel each other. So what happens is, when we add a second electron to that shell, we have to have it in the opposite spin. And so now our north pole and south pole of the 2 different adjacent electrons will pair up together, and that'll decrease the energy it takes those 2 electrons to travel around in that orbital. So as we fill from the bottom up, we put 1 electron in, then we spin pair that electron, and then we can add electrons to the next level. Okay. Now, protons and neutrons also have spin, and we're going to use that when we talk about nuclear magnetic resonance spectroscopy. Okay. So as we fill from the bottom up, hydrogen only has 1 proton, and therefore in its neutral state it has 1 electron. That means that that 1 electron has to be in the first energy orbital, it has to be in an s orbital, and there's only 1 electron. So that would give us our 1s1 configuration here. Okay. Helium has 2 protons, and therefore in its neutral state it would have 2 electrons in its outer shell. That would fully fill our 1s shell here. So now, with our first 2 elements, we filled our number 1 primary energy level. Okay, and that means we now have to go up to our second energy level, which is our 2 energy level. And the first orbitals we're going to fill there are going to be our s orbitals. And so lithium is our next element up. And so we're going to put our 2 electrons in our lowest energy level, our number 1 energy level. And we're going to put 1 electron in our second energy level. And so that 1 electron has to go in our second s orbital. Okay, so it's our s orbital in our second energy level. Okay, so as we build and build and build, what we end up getting to is, if we get to carbon right here, you'll notice that we have 2 electrons in our s primary orbital, number 1. We have 2 electrons in our energy level 2 s orbital, and we have a total of 2 electrons in 2 of the p orbitals. That's going to help us later when we talk about hybridization, so keep that in mind. So then, as those electrons fill and fill and fill, we can fill all of those energy levels until we get to the state neon here at the end of the periodic table, where all of those energy levels are full, and now we have to go up to our next energy level, which would be energy level 3. Okay, so that being said, most of the time we have to deal with our carbon, and so we're looking at that number 2 energy level. Oops. Okay, so now, do you have to memorize where all these things are? No. You can use the periodic table to tell you what electrons are where and how many energy levels are filled. The way we look at that is that this right here, if we look at this first row across here that has the hydrogen and the helium, that's our number 1 energy level. Okay, so that means that this right here is our s orbitals, and this is also, for helium here, has an s orbital. Okay, so we could actually put helium right here because it has s orbitals in the 1 energy level. When we move down, we have the lithium, boron, carbon, all the way over the fluorine right here. This is our number 2 energy level. So again, the first 2 electrons are going to go in here into the s orbital. That makes all 6 of these over here our p orbitals. Okay, so this would be our first electron in here would be into a 1p, into our 2p X, 2p Y, 2p Z, and we keep adding electrons into the system as we go. So if we followed that table from the previous slide, we can say, okay, this has to have S1, and there's 2 electrons in it. Then we have to have S2, and there's 2 electrons in it. And then this first right here is going to be our first electron in a P. And this will be our second electron in our P, third electron in our P, fourth electron, fifth, and sixth until we fill that level up. So we can use the periodic table to figure out how many electrons we have, where they are. And we're also going to use that to figure out how many valence electrons we have. So keep in mind where the different orbitals are on the periodic table, and you'll be able to find them. Now, okay, so what happens to our P's when we go to the next level? Well, this is our 3s level, and this is our 3p level. And guess what? Here is our 3d level. This is where our d orbitals come in. And then once we get way up here, we can get into our f orbitals here. We are not going to use those very much this semester, but the most important ones are the p orbitals that are in the second energy level, and how many electrons we have on our second energy level. And that concludes Chapter 1, Section 1.